This conference will now be recorded.
Hi, good morning, everyone. Today's topic is TAM V2. We are going to continuing the discussing. Before that, a small announcement that OCP networking group is preparing for a workshop, and at the end of August. Tentatively date is August 30th. The details is still under work by Omar, Scott, Archana. This is one day workshop that different project will be there to talk about the software or progress. The location will be in California, Silicon Valley. There is no detail yet. They are working on the host company and the timing and agenda. We will let you know once it's clear as soon as possible. So today, Jay will continue the telemetry and monitoring V2 discussing. Yeah, Jay, would you like to dive on here?
Yes, thanks, Jen.
Thank you.
Okay, guys, so just to have a quick recap on the discussion which we had last week. The topic we wanted to talk about was the GET APIs and a quick recap on the problem statement. The data which was streamed out on a streaming channel was also of interest from the local NOS for retrieval, which is the synchronous GET APIs, GET data APIs. And I proposed a model, and the model is very simple, where the data which is modeled in the Google Protobuf language, IDL, is presented to both on a streaming channel as well as to the NOS on the local channel. That was the very basic idea, and let me just quickly go over. So this was the idea that we have a data which is produced by the switch, is consumed by the SAI driver and presented as an opaque blob through the API to the NOS, and NOS can consume it after the deserialization, or if there is any other higher level entity sitting on top of NOS, then NOS can also present the same data to the higher layer. And since it's a binary encoded data with very well idealization, it can be deserialized by the higher level entity. And the idea there is that we avoid doing the screen scraping and understanding of the XML data. Today, what typically the controllers do, where they do the screen scraping or decoding the XML data. So that's a high-level model which I proposed. There are a few things which are of interest, which I expected some level of discussion, which did not happen much. So I made an assumption that probably I was not able to explain in detail. So I'm gonna critique my own proposal so that at least there is a discussion on the topic. So one of the problems you see in this proposal, let's see if I am able to get to the so let me do a workflow will and then I'll come back to the okay, let's do that relationship. So this will also open up probably make a better understanding and also open it up for the critique. So if we see in this model, there is one and only one API to get any kind of data from the switch, and the API is simple get data, right? And the parameters which we are going to pass in this API is a parent object for which any data is requested. So you have to give a SAI object, which is the parent object, and also provide a buffer and the buffer length. So that's what this API takes. And the parent object, along with the attribute list, will provide the walk down on the data which need to be collected. Okay, and as a completion of the API, the buffer is populated with the data. Amount of data which is returned in the length, and there's a return status. So it's a very, very simple API, and there's only one API. And if we go, then the parameters are going to look like this. The parent object, which is being passed as the parameter of the API, that is, let's say, the switch object. Then the children object, which can be specified, are only immediate children. You cannot specify a child of a child. So here, port is a child of the parent object switch, and you can give a list of port, not just one port. And if there is an absence of a port definition where we say just parent object and do not give the child object, then one or more child objects which are present for a given parent, all are presented as a return data. So that is kind of an ease of use where you want coarse granularity of the data. And if you want a finer granularity, then you specify a port. And within the port, you can also delineate that there is ability to specify that do we want ingress stats or egress stats, or you can specify both. Okay. And in this model, so this is one example, and I have a workflow through the API as well. And another example is, let's say I want a queue stats. And in the queue stats, essentially the parent object in this case will be the port, where a given port is queried for the queues, and queue you can list one or more. And within the queue, this is just cut and paste, apologize for that. You can have queue stats or queue error stats kind of granularity, and you can request one or more granularity, right? Now here is my critique to this, that in an ideal world, I should be able to say that give me only packet byte on a given port, right? Ingress packet byte count on a given port. That is the finest granularity of request I can make. In this model, if you see the request which is being made through the API kind of stops at some coarse granularity. It does not go all the way to the data field itself, right? And the data field definition is in the proto file. So I have example here for, let's say, egress port stat. What does egress port stat means? All the data fields are defined in the proto file, but the API itself does not give a ability to request individual field, right? So that is one critique I can make myself of the API. Now there are pros and cons of both the things. So I'm not going to go into the pros and cons, but that's one issue I wanted to point out, and I want a team to see if they see a benefit or if they see a negative side to that. So that's how the API is going to look like. There is a one and only one API, which is invoked with a parent object, and then there is a list of child objects, and child object may request some level of granularity of the data. So that's the API proposal in detail. Any questions on this? Okay, so let's see if we have a example.
I have a quick question.
Yes.
Which is related to, so I'm trying to, I really don't know. It's not like whether we are taking that like in the wrong layer, seeing that SAI is like driver and this is like more like higher level API layer that I expect to see it from the higher level, not from the SAI. I'm not sure what is. It looked to me like that we are making the driver now kind of application.
That's one way to look at it. And other way to look at it, that once you implement the driver, as far as the API handler point of view is concerned, once you write the driver, your job is done. That's another way to look at it. So if we take
What
an
do you mean?
example,
What do you mean my job is done?
the
Assuming
example,
that the format is the format that I expect to digest the packet.
right. So
Uh,
in this model, let's say that take an example, right? Let's take an example. So we have port stats, very simple example. Today, SciDriver does a collection of the data, which is pulling the information through various lower level APIs. It
mhm.
formats into some format which is specific to the whims of the API implementer, the driver implementer, and then it presents the data the way it feel like. There is some formatting which the engineer does, right? There is no standardization on that.
Yeah, but probably moving forward, there will be processing that done on the data locally. You won't forward it like the way you receive it from the hardware as it is. Otherwise, it won't scale. So probably,
So,
as I said, what we would like to do is to have some local processing on the data and then send a portion of it to the remote.
a remote, as in the NOS.
No. So no. So to some kind of collector,
So that is the streaming part, right? So that we
right?
discussed. Yeah. So that is the streaming part.
Yeah, but
Okay.
I don't think that the only way that I can work is streaming the raw data. I think that this is not scalable. The idea is to actually, as I said, and we saw a few examples for that in real life scenario in which we are trying to optimize actually the SAI API to the lowest granularity, because there will be some request to get some data in a very low granularity and some other data in some other granularity. Like, I don't know, PFC Watchdog, I would like to monitor the buffer in a very millisecond time frame, and other counter I would like to monitor in a minute or so. So I think that for the driver perspective, what I expect to see, like, it is like bare minimum, very very like primitive API, and the NOS above can wrap it or in different ways. I'm not sure that again this what I will ask a different question. What is the benefit of doing all the serialization in the SAI layer itself, like
Right.
creating?
Yeah. Good. So I'm trying to figure out that who is speaking in this so that I can put the voice to the name, and I
Sorry,
don't have a good way of figuring it out. I'm trying to.
sorry. It's Mati from Mellanox.
Uh, it's Michael.
Mati from
Oh,
Mellanox.
Matty. Okay, got it. Okay, got it. Okay, got it. Sorry. Thanks, Matty. Yeah, I was trying to just figure out from the meeting itself that is there a way I can, but there was no good way. Okay, so you're right. Okay, so that's the discussion I wanted. I wanted a critique so that at least I can put my thought process around, and it's just my thought process. It needs to be refined or maybe corrected, right? So few things. This API is essentially is equivalent. It's not trying to replace the show commands. Today we have the show commands, which are handled by the side driver. And it is not trying to replace, but it's providing some capability for the show commands. So that's one thing I wanted to highlight. This API is not talking about the streaming. Streaming model we finished, where we talked about it, and it was actually a much bigger collection of generic objects in which you can squeeze in pretty much any kind of data type, right? It is that fairly generalized, right? So I just wanted to make that point. This API is essentially, if you look this API, you can replace it with some show command, any show command, show port stats, show L2 VPN stats, show route stats, something like that, right? So this is what we are talking. So Maddie, I just wanted to make clear, is that understanding clear?
Yes, it is.
Okay, good. So now the question you're asking is a valid question that uh, first, why I am doing this? I mean, I already have a notion of show commands. Then why the hell I'm even worrying about this API today when SAI driver is written for, let's say, E over MPLS or L2TPV3 or some forwarding layer, then the driver itself provides all capabilities of the show commands where the data is exposed to the NOS, right? And remember, we are just talking the interaction with the NOS, not the external collector. So that's where the argument starts showing up, okay? And although I said that we are not trying to solve that problem, we are trying to solve a little bit different problem, but I still give a perspective on the existing implementation. So today, let's say I, as in a SAI driver for a given feature, does an implementation. Then which API I create to expose certain data from my driver is completely at my whim, the way I feel like, right? And then I say, if you want the L2 VPN stats, that is the command. Go use it. Okay. If you want any other forwarding feature, RPF or whatever, right? Here is the command. Go ahead and use it. And then the onus becomes on the consumer, which is the NOS, first to understand the new API and then keep on writing the parsers for those API, which is essentially the interpretation of the data which is being provided by that API, right? And I see, and that's a very, very inefficient model, and a lot of people are already trying. I mean, Cisco is trying to solve that. I was in Juniper. Juniper has done a common data model internally where API name could be different, but internally everything is seamlessly presented as a single way, which is essentially, again, using gRPC and protobufs.
Yeah, I agree, but you're referring to different layer. You're referring to Juniper as a NOS provider, not as a silicon provider. We size
No,
a silicon driver.
I'm talking about the silicon. So I'm talking about the internal. So when I talk this layer, essentially I go inside into the Junos, and then there are different layers, and I'm talking about that. Okay. So I'm talking about then even with there are my consumer itself is the Junos when I'm writing my silicon drivers. And the same problem, same questions arise there. The guy sitting in the OS, the Junos layer, questions me that why you are implementing again and again new API. I'm just going nuts supporting these APIs. Why can't you give me a single standardized interface with a standard data model, right? And think about it. And remember, I'm not solving that problem. I keep on repeating that. I'm not solving that problem. I'll come to problem what I'm solving. But just from a conceptual point of view, if you write a side drive, a NOS guy says, here is one API. You want to give me any data. This is the only API I'm going to invoke. Okay, all you tell me what is the qualifier of the data and give me a serialized data, which I can deserialize it myself. Then the job of the side driver becomes very easy. He does one-time implementation of that API. Okay, and then as the data is produced, since remember, I'm not putting the data fields into these objects. Data fields are hidden in the proto file. So this layer, this API layer never changes. That's what I meant by never modifies, right? You specify new data, it magically appears to the NOS. But you're right, NOS still has to interpret the data. But as far as the infrastructure of implementing the API, he's done. Once he implements the get, he's done. All he has to do is when the new data shows up, he makes a new model. Okay, that's the argument. That's the argument. But remember, I said I'm not trying to solve the problem. Then what problem I am trying to solve? The problem I'm trying to solve is, which was given to me, which I was very reluctant to handle because I see there is a contention. The problem was that if there is a data which is being streamed to an external collector, there is an interest in the exact same data locally. Why I cannot retrieve that data through a synchronous API? That was a problem which was given to me. And for that problem, I'm saying, yes, you have a single API to query any data which is streamed out, and there is a way to qualify that data through the objects. I'm not going to create a data-specific API. That's the stance I have taken. Now, can this model be extended to other show commands? Absolutely, it can be. Am I mandating that? No, I'm not mandating that. Does that make sense?
Yeah.
Right? So it's a very, very contained domain which I'm trying to solve. And again, in one line, the problem definition is there is a data which is streamed out to an external collector. Same data can also be retrieved by the NOS API. Okay. And since my data modeling language to an external collector is protofile, I maintained the same modeling language for my local consumption. And there are inherent benefits of doing that. The one thing which I have deliberately not done, I did not expose the data field into the query layer where you can specify the data field. The moment I do that, okay, the reason why I did not did that, the moment I do that, then my whole argument of this red framework being once written and done goes away. Because I mean, you can still do that. You can have an enum definition, which you can keep on expanding it, but still a driver change. And in this model, the only change is the proto file change, and you compile it. The serialization APIs get auto-generated, which are already invoked by the driver, and there is nothing else we have to do. But thanks, Mary, for questioning me. If you gave me an opportunity to clarify my thought process. And I see Senthil is also there on the call. One of the requester for this was Dell. Senthil, do you have any opinion on this? Okay, probably Senthil is on mute. But Dell had a request. Senthil, sorry, go ahead.
So I mean, we can, it's Mike Lazar here from Dell. So I can ask Senthil, but he's our, expert on this topic.
Okay. So let's go on the workflow and see how the workflow looks like in this case. Okay. So the workflow here is very similar to the streaming API invocations, the streaming object creation. It's very similar with some delta into that. And that's again very deliberate, because when I'm writing a driver, I should be able to provide as much as commonality between the two frameworks. So here, if you see, this need correction, sorry. So step one, we create that, what is the parent object? What is the parent object which we are talking about? This step one will go clean this. I forgot to clean it up. It may completely go away as well, because the parent object is specified in the API itself. This is the second step, which is the report. And report here saying is type proto. Now I deliberately kept the report object here, and that goes to what Matty was saying, that in case, let's say I do not want to do a serialization, deserialization, but I want to give a report which is fully cooked, and somebody need to just parse it and understand it. In that case, this field can be extended, right? I would not prefer to do that, because that breaks the paradigm of the proposal. But let's say if there is a strong need, the framework provides ability to break that paradigm. So you can actually specify a different reporting object, which is completely proprietary. You can just say vendor extension and forget about any standardization on the data model. And then finally is the data object itself. And here, data object is essentially a collection of the report type, what is the telemetry type we were interested in. And then here, if you see, we specify what is the list of child objects. And if there is no child object specified here, it means for that given parent, which is invoked in the API itself, for this parent, all the children which are, and remember, the rules here are implicit. There's no explicit rule. I have captured it, one of the notes. All the childs will be invoked, and all the child's data objects, data fields will be provided to the consumer. If it is specified, then you can go and specify what all port objects are there. So you can do one thing which would have been good to give a regex kind of ability, but in the API, it's very hard to specify the regex. So I have First cut, I have not specified it, and we can see if there is a way to bring it in cleanly. Essentially, you can say if you have a port qualifier, then you can say all the XC star dot star, right? Or if it's a 100 gig, then you can say if or it's a lag, then you can say a different way. That's where the regex becomes more interesting. Otherwise, in this proposal, you give an explicit qualifier for the ports, and then provide what are the data IDs. So data ID is applicable to all the child objects. You cannot specify that port 1 gave me only port stack, port 2 gave me only errors. So there is some inefficiency which is built into the proposal, but this is the first proposal, so I wanted to go with the simple approach first and then improve it as we go. So in this API will be invoked with a switch object as the parent, where the child is the port, and the request is coming for 2 ports, and the interest in the data is port stats and port errors, right? Which will be both ingress and egress. So that is one way to invoke the API. The second way to, let's say I want to do the queue stats. In that case, the parent object becomes the port, a given port, and then child object is specified as Q1 and Q2, and the data field for the child are what is the data field for the queue. And in that case, the API is invoked with the parent as well. So API remains constant, as you can see here. Okay, so that is the workflow on the API. This is how the objects are going to look like. And if you see the definition, there is no there is loose coupling. There is no tight relationship. So the get data enumeration essentially says that a child and what are the data IDs which can be supported by a child. The child objects are the standard SAI objects. There is no new definition for it. We already have objects defined for port, queue, anything which we need data on. Those objects will be defined by that feature implementer. And then the data part of it is what is being handled by this set of APIs, where we come and define some granularity of the data in a common enumeration. Again, you see there is no binding of a child to the data ID. It's a loose coupling. And we can improve on it later on as needed, but that's how it is right now. So all the data types today will show up in this one enum, which will keep on going to a pretty large value. So that's the only change. The change to support the GET API in this model is limited to this. It's that simple. And as far as the invocation is concerned, it is limited to a single API. So the whole framework is extremely, extremely simple. Now, after so much of thinking, I have Tushar also with me on the line. We spent quite a bit number of hours just discussing this. And it got simplified to just one API and 2 enums. So that's on this. And then there is this constraints and benefits, which I was talking about. That parent and child relationship is loosely coupled and implicit right now. It is left to the implementer how they want to identify that relationship. If somebody implements a wrong relationship, that will still be accepted. We want to reuse the existing SAI objects. This API does not propose to create any new objects. The only thing it's going to create is the data ID. Multiple data ID can be specified, okay? And that's the thing which I talked about earlier, that data ID, scope of the data ID is to all the childs which are specified in the API. You cannot create a scope which is to an individual child. Unfortunately, that's a little bit difficult to do. So right now we left it there. Another constraint which I have put, and these constraints, the reason I have put, it just makes my implementation a lot more easier. Does it make it very efficient in terms of concept? Probably no, but implementation-wise, it becomes very, very easy. Hierarchical child objects are not supported. What does that mean is If the parent is switch, the only data you will get is all the immediate childs, which are all the, let's say, port stats. If you are invoking API with the parent as a port, then all the child of the port are only objects which are addressable. You cannot go within the queue. Like if the parent is switch, you cannot go port and then also go in the queue. That's not allowed. So you will only be able to get the ports. If you want the queue, then you have to invoke another API. That's a little bit inefficient, but that's how it is done right now. And then there is some level of wildcarding which is provided, and where if the child is not specified, then you get all the childs of a parent. Or if a child is specified but the data ID is not specified, then you get all the data of a given child. So that's essentially a wildcarding. So there is a level of wildcarding which is provided, and then on the data, this is how the data is going to look like. So let's take example of the port stats, right? So here, now this is just an example. This is not a proposal, by the way. So in this, there are some fields which are mandatory. So, and remember, this data in this file is not addressable by the API. That is the data which is provided to the consumer. And in this case, if you see all the objects which we created, so let's take an example. Let's go here. So we created queue stats, port stats. I have not put the ingress and the egress, or the port stats. So here you see port stats essentially corresponds to, and the name will be same. So when I change it, these names should be same so that there's a one-to-one relationship. If you see the port stat a hierarchy, which is specified here, which gives the data here in this. This is the data. Right? And then this data can be addressed for ingress or egress. And same thing is for the errors. So this is the errors, and errors can be addressed ingress, or it can be this is actually wrong. It should be interface errors. So that's the data model. It's relatively simple, and same thing is queue stats. So queue stats is single hierarchy, which can be addressed in a direction ingress or egress. And this is what translates into a data ID here. Right? So that's how the relationship will be done. Right now, it's manual. I'm pretty sure we can write a script to extract it and generate this enum in an automated way. That's probably the long-term goal, that once anybody writes a proto file, we will have annotations of these fields, and then the script runs and extracts it and creates an enum or appends it to the well-known enums. So that's the next step, which probably we will try to show. So that's pretty much it from my side. Jin, that's the proposal I wanted to discuss for today, which is the implementation of the API itself, how it will look like, what is the data model, and what are the different objects it's going to handle.
Thanks, Jay. Any comments or thoughts, feedbacks?
Hey, thanks, Jay. This is Senthil. I tried to talk before, but somehow it was the app and the phone. Both needs to be unmuted, I guess. So this is good for at least from what we discussed earlier, right? So this is what we are looking for from the Dell side, to have the same interface for the inbound as well as for the local gets. The one thing I agree with Matt on that was the initial thing. Also, we requested a little bit more granularity. So I think we had to work towards it. It's a really nice proposal. We can refine it to support in a more granular fashion. The other comment I have is on the API itself, on the buffer and the buffer length. How would the application figure out that when the driver implement the driver, right? Because it's a multiple object, you're filling up the parent and the child as well, right? So
right.
Part, I think we need to modify that part of the buffer pointer and the length.
So let me tell you how it works, right? So the way it is going to, and that's very standard into the protobuf world. So buffer pointer and length is given with an assumption that you don't know what's the length in that case, right? And this is, I think, still not complete, and you will realize that there is something missing here. I realized it yesterday, but I left it because I've already shared the slides. So the way it's going to work, let's say the API get invoked, buffer pointer is given, buffer length is, let's say, 100, pick a number, 100 bytes. The data which got generated is actually 120 bytes. So what driver will do, driver knows the buffer length, it will say that I'm able to give port 1, port 2, port 3, okay? And there was a more data which I was not able to fill in, right? So it will give some, there has to be some indication where it will say that there was this much of more data which was available with me, and which I could not uh, could not furnish because there was not enough buffer. Now the
Hey,
question.
Senthil, this is Tushar. So I guess we could use the same, the buffer overflow mechanism that the SAI spec has currently.
Okay, I am not aware of that. I'll take a look at that.
Sure.
To see.
Yeah, one is that you just stop everything and just return the status where user buffer overflow. And then the problem with that is you still want to know what is the actual buffer length of the data which was supposed to be produced.
Right. So the length is the in out, pretty standard in the SAI spec. So when we do the overflow, we send the actual length so the application knows for the next call.
There we go. Wonderful. Yeah. So that will work. Yes. So that's one way to do it. And other way to do it is that you provide the data whatever you can and give the hint that how much of a data which is still being left. So you give overflow condition, you give the data what it can, and you also say that how much of a data which was not provided.
Okay.
So there are many ways to solve the problem.
Once again, thanks, Jay. That's it from my end.
Okay, thanks, Anthony.
Jay, one query for me, like we created like a parent and child, right? But if you take like if I want to get the queue level statistics, how to give parent as the port and queue as the child object, right?
Right.
So, but queue itself is defined as an object. So, why I need to give again parent of that queue? Can I give directly the queue and get the statistics or something like that?
So queue is always in a context, well, depends on the queue types also, but typically queue is in a context of a port, right?
Yeah, but
I
while
guess,
creating
I
queue
guess, I
itself,
guess we could support both, Jay. We can discuss offline, but let's say, I mean, if you're only interested in something specific, then it makes sense. But yeah, I mean, what he's saying is basically the queue object ID is fully qualified. It has the context of the port as well. So maybe we can think about that and
The
tweak that.
SAI object is, I see what you're saying. I see what you're saying. The SAI object itself has qualification for the port also. Then why? Okay. Uh, are there any objects which don't have a qualification, or they're always qualified?
I guess the ones that we have mentioned so far, they are pretty much qualified. We can look at more examples and figure out if there is something that is not qualified currently, not an object. So anything that's an object basically has its own personality and identification.
Got it. Got it. Who was that?
and
I didn't got the. Who was that?
this is Ashok from Dell.
Hey, Ashok. Okay. All right.
Hi.
Yeah.
And the
So,
other
okay.
thing is whatever we are adding in this protobuf as new, like new statistics or something, same thing will be added to the regular port object, or but I didn't get that fully. So,
it's
or it
it's
will be
gonna
there
be,
in.
yeah, it's going to be vice versa. What is there already in the port object will be added here.
Okay.
Yeah. So we will take whatever we support and try to create a generalized names. Uh, And essentially, if you see, all the fields are, I don't know if you can see that, but all the fields are optional. So let's say that there is one chip vendor which supports some fancy stats, or let's say the port itself is, let's say, a fiber channel port, and there is some information which is not applicable to other Ethernet ports. You can
Yeah.
still add it here because there's just a union and everything is optional.
Okay.
But the way we will start, we will take the current definition of the port stats, for example, and the queue stats, and we plug it into this data model.
Okay.
And also on the data model, the way we are thinking right now is we will have a common repository for all the proto files, which will be invoked for serialization. So there's a common repository in the GitHub for the proto files, which will get compiled by the proto compiler, and it will generate stub functions, and they are common libraries. Driver will include them for serialization. So that's a common lib which driver has to include. And then it will call the serialization APIs, and same common lib must be included by the NOS, let's say Sonic, to call the deserialization API. That way, there is no synchronization issue, or there's no that the consumer and the producer goes out of band. That never happens, or they always remains in sync.
Okay. Okay.
Okay, thanks, Ashok. Tushar, do you have anything to add on this?
No, that's it.
Okay, Jin, so that's pretty much it from our side. I'm going to stop sharing.
Thanks, Jay. So I believe that probably everyone would like to take time to go back to go over this again and think about it. Jay, for this slide, can you share? Can you send me to share to the community with the community?
I sent it yesterday, Shit,
on the mailing list?
Yeah, on the mailing list.
Okay, I missed that. That
Yeah.
will be great. Yeah, that's great.
I can send it to you again, and you can share it.
No, I can go to the community mailing list to check that.
Okay.
That's great. So as the next step, I would like call out to the audience that to put your comments into the pull request. This is, I mean, getting close to have all the agreement.
Jin, this new API that Jay just described, I still add it to the pull request, the get API. That's pending.
Do you know the timeline that?
Yeah, we'll do it like in the next few days.
Next few days, okay. Sure. They have next week. Yeah, they have next week before next meeting, group meeting, to comment, to take a look. Yeah. Okay. I think with that, we will let everyone to take it offline to read it through, or they can review this meeting recording and come back with comments the week after next. Hope we are making great progress here. Yeah. If there is no more comments, then we are going to return 10 minutes to everyone. Yeah, thanks for your time.
All right.
Talk to you next week. Thank you, Jay. Yeah.
Thanks. Bye-bye.